Now we move on to standard deviation. So I'll explain how to compute the population standard deviation. What we use is a symbol called sigma. That's for population. So sigma is going to equal the square root of the summation of x sub I minus mu squared all over capital N. So standard deviation, this shows how spread out the data is. So is it close together or far apart? We will be using number 1 for the calculator command to find the standard deviation. So compute the population standard deviation of the test scores above. I want to do this by hand so you can visually see what we're doing, and then from here on out you can always use your calculator. Even if your homework says do it by hand, use your calculator, I am fine with that. So what we're going to do is compute xi minus mu. So we're going to work on this inside first. Xi is going to be just the corresponding score, and then mu was the mean, and we figured out that was 79 in 3.1. So this is 3. Then 77 minus 79 is negative 2. So on and so forth. So we have 11, negative 8, negative 17, negative 11, negative 5, 5, 15, and 9. So when you add these all together, you're going to get 0. This is always the case. This is called the sum of the deviations about the mean. So let me just give you a visual of what these are actually saying and doing. So we have, let's get this pen going, we have a curve, bell-shaped. Here's our mean. Our mean's always in the middle for symmetric. Okay, so the first deviation was 3. So if we go up 3, then we can go back down 2. So right now we're at 1. Then the next number was 11. So we add 11 to that. So 1 plus 11 is 12. And then if you go back, I'm just using these numbers. So now we're on negative 8. So negative 8 from 12 will give us 4. Then negative 17. So 4 minus 17 is a negative 13. Minus 11, which is a negative 24, plus 5, which is negative 19. Oop, and then it's supposed to be minus 5, sorry. So negative 24. And then we have a positive 15. So it's going to give us to 9. And then a positive 9 brings us back to the mean. So all it's saying is all those deviations, it's always going to bring you back to the mean. So that's why it's 0, and it will always be 0. So I hope that visual helped you. I was just explaining that that's how we get to 0. So the next part is the sum of the squared. So we're going to square this now. So xi minus mu squared So we're going to take this number and square it. So 3 squared is 9. Negative 2 squared. If you put this in your calculator, be careful. You need to put parentheses, negative 2, then square it. We get 4. Negative 2 times a negative 2 is a positive 4. 11 squared is 121. And then 64. 289. 121. 25. 25. 225. And oops. And then 81. Add those together, we get 964. This is equal to your summation of xi minus mu squared. That's this portion right here. Now that we have that equal to it, we can write 964. What is our n? Our n is 10 because we have 10 in our population. And then we take the square root. So when you get that, your standard deviation is 9.8. So let's try to do this on our calculator and see if we can get the same thing. So we go to Stat, Edit, put your information in the list. I have done that already. Step B, go to Stat, Calc, OneBear Stats, and then we're going to do List 1. So if you do have this calculator, I would maybe make some notes on your note sheet of anything that you might not be certain on. And even if you do have these calculators, if you're still not sure how to do something, write down. These notes might not be perfectly clear. So right here I'm seeing sigma is equal to 9.8. And that's what we calculated right here. Okay, so we just did that. So I'm just going to write C above. So if a data set has many observations that are far from the mean, how is the standard deviation affected? The standard deviation, let me type this. Standard deviation would be large. So now, how do we compute the sample standard deviation? S equals the square root of the summation of xi minus x bar squared, all divided by n minus 1. This n minus 1 is slightly different from the population because we just use the population size. This is referred to as degrees of freedom. If you want a more in-depth explanation, go to the interactive 3.2 and then go to objective 2, page 6, and it'll explain exactly what the degrees of freedom are. But I'm not going to get into those details here. The way you calculate this is again on calculator command number 1, and it's going to be S sub x. On the first page of chapter 3, we obtained a simple random sample of exam scores and computed a sample mean. Compute a sample standard deviation of the sample of test scores for that data. So we're trying to find the sample standard deviation, so we should be looking for S. And what were those 3 scores? They were 77, 68, and 88. $77, 68, and 88. Okay, so I'm going to use calculator number 1 command. So we're going to go to Stat, Edit. Now I'm just going to put those 3 in the next list. So we have 77, 68, and then 88. go to Stat, Calc, One Various Stats. Now this is in list 2, so make sure you put list 2 here. And S of X is 10.0. So approximately 10.0 points is the sample standard deviation. Is standard deviation resistant? It is not. Extreme values have a large impact on the standard deviation. Standard deviation typically represents the typical deviation from the mean. It can be used to judge whether an observation is far away from the mean of the data. A good rule of thumb is to consider an observation far away if it is more than 2 standard deviations from the mean. Is a measure of 31 centimeters far from 25 centimeters? It depends. If the standard deviation of the data is 6 centimeters, then the answer is no, because 31 centimeters would be only 1 standard deviation from 25. However, if the standard deviation of the data is 2 centimeters, then the answer is yes, because 31 centimeters would be 3 standard deviations from 25 centimeters. So let me just kind of do the second one so you can visually see 3 standard deviations. You have 25. You're going to add 2 to get to 27, add 2 to get to 29, add 2 again to get to 31. So here you have 1 standard deviation, 2, 3 standard deviations. If our standard deviation was 6, we just had the 1 standard deviation. So this one would be far away. When we compare 2 or more populations, the larger the standard deviation, the greater the spread or dispersion of the distribution, provided the variable of interest from the 2 populations have the same unit of measure. So, for example, dollar to dollar and not dollar to yen, or like inches to inches, not inches to feet. Okay, so I would like you to watch this video and then resume this lesson to get a better idea. As the spread increases, the higher the standard deviation. As the spread decreases, the lower the standard deviation. So then, what do you think a standard deviation of 0 means? It means that all data are the same. Here is a visual. So if we do a dot plot, imagine these are exactly over top of each other. These data points are not moving at all, so there is no spread. So a standard deviation of 0 would be this. If you put one over here, we're automatically going to have some kind of a spread or standard deviation.